Hey everyone, so I got a request for this video actually, and it might seem to some of the people who are watching this series may seem like a step backwards, but it's really not. So today we're talking about something called nested loops, and so nested loops can be a little bit scary just because they're hard to visualize. And the more that we get, the deeper we get into the nest, like the more we start nesting loops and nesting and nesting. Now obviously there are other things to handle when we're getting too deep into this. There's probably other methods that we could be using, but as you get further into the nest, all right, it gets a little bit more complicated to understand and to work with. The same thing with like arrays, right? One, two-dimensional arrays are not so bad. Three-dimensional arrays maybe not so bad. But the more that we start to add, the deeper we get into the array, it starts to get really hard to manage. And so but for doing, simple kind of things like what we're going to talk about today is like printing a grid, for example. Printing a grid is a great example of something you can do using a nested loop. Another example will be anytime that you want to run like some really simple, easy sorting algorithms. We're going to kind of design like a makeshift sorting algorithm on a really, really, really short array because it would be completely inefficient for anything bigger than, yeah, I don't know, 20 or 30 numbers. But anyway, so I'm going to show you two really cool examples, or two really quick examples. They're not exactly cool, about nested looping. Okay, so a nested loop is kind of like this. I'll explain it to people. Okay, so if you have a box, you have a big box, right? And you want to open that box. Let's say maybe you have two big boxes next to each other, and you know that you want to open that first box. Okay, but when you're in that first box, so let's say you open this box, right? But when you're in that box, there's three other boxes. There they are. There's three other boxes. And you want to open those too, okay? And you want to open those before you open the three boxes that are hidden in the second box, okay? So this is a great example of what you would use a nested loop for. The outer loop is what's going to allow you to open the big box, right? So you open this big box using the outer loop, you go into the box, and then your inner loop is going to allow you to open up these three boxes, okay? Then when your outer loop increments by one, you move over to the second big box. We jump inside and we do the inner loop again, which allows us to open the three boxes. So we can open all these boxes by using, relatively pretty small pieces of code, if not, just a couple of lines of code. So I'm going to show you today another really good coding example, especially if you're in game design or graphic design or anything, is printing a grid, okay? So printing a grid usually looks like something like this. 1, 2, 3, 4, and then you've got like 1, 2, 3, 4, right? And I don't know how you might be organized. You may just have ones down through here. You might have 2, 3, 4, right? So you may just print the same thing 4 times. You may and all of them can be done using the exact same way. And what we're going to do today is we're going to create like a ladder grid. And it's going to show you a couple of different things within the same example. So what we're going to be creating is something like this: 1, 1, 2, 1, 2, 3. Oops, 1, 2, 3. 1, 2, 3, 4. Remember, these videos are not rehearsed, so that's probably you're seeing it in the raw. So we're gonna create two loops that will go inside of each other, and we'll have an outer loop and an inner loop that's going to create this shape. And it's actually really simple, and you can use the same process to print any kind of grid that you want. So the first thing we're going to need to do is create our outer loop. Okay. Now, for this one in particular, we're going to have a variable called rows. All right. So we're going to say int, and you don't have to specify like in most languages. So we won't for this one just because we're just going to use kind of pseudocode. So we'll just say that rows equals 5. Okay. And that's the number that's the number of rows that we're wanting to do. Now you could increase this or whatever. And what's really cool about this is that you could actually just change this one variable and you could change the whole ladder that we're going to create, or the steps, or whatever you want to call it. So we're going to create our outside loop. And we're going to say for I equals 0. Okay. And then we're going, and remember, this is like the three parts of a loop. And we're not going to like go over all the different parts of a loop really quick, but these are the three parts of a loop. You have to give give your, iteration variable, whatever you want to call it, some kind of value, which is usually going to be 0, especially if you're going through an array. It's usually going to start from 1, right? Or 0. Or 1, depending on the programming language that you're looking at. Then we're going to say I is less than or equal to rows. Okay, so that we're saying that as long as it's 5 or fewer, then we want you to keep going on the outer loop. All right, and the outer loops is our rows, right? And that's pretty common too. Anytime you're doing a grid, your outer loop's going to be your rows, your inner loops are going to be your columns. Okay, and then these are all things that you can write down in your little recipe book, which we actually talked about the other day. So and then let's just say plus plus I. Okay. So what we're doing here is we're saying, okay, we're setting up our loop. The first part says I equals 0 initially. This one tells us when to stop, and this one tells us what to do after it's been executed one time. Okay, so we're going to increment I by 1. Okay, so this could be different depending on what programming language you're using. It could be I++, it could be I plus equals 1. Doesn't really matter. Okay, So now we want to get into our inner loop, okay? So right directly into our inner loop, we're going to say for j equals 0. Now, j is pretty common. I mean, a lot of people use j. You don't have to, but you can. And actually, hold on one second. I'm gonna replace these zeros with ones, because what I was saying earlier is if you're using arrays, it's great to start with 0. But in our case, since we're doing this little grid and we want it to start with 1 rather than 0, we're gonna start with 1. But if you're working with arrays, you're usually gonna start with 0. Okay. Now this is gonna be a little bit different. We're gonna do j is less than or equal to I, right? Because this is okay. Cool. And so, like, yeah, I've got like a couple notes written down, so I didn't forget what I wanted to show you guys. Plus j, okay? So this one's a little bit different. What we're saying is, okay, we want you to do we only want you to do this as long as j is less than I. So that's going to be different for each one, and that's what we want, right? The first row we want it to do just one letter or one number. The second one we want to do 2 numbers, then 3 numbers, then 4 numbers. So this makes sense, right? We only want it to loop as long as j is less than or equal to I, which will increase every single time. And then down here inside of the little one, we just need to tell it what we want it to do, and all we're going to be doing is printing j. Okay, and if you want to make it look pretty, you put like j plus space or something like that. Is probably what your programming language would do, or we can put little parentheses around it, right? But remember, when you're writing pseudocode, it doesn't really matter. So what is this going to do? So let's just go through this, kind of like we did with recursion. Let's go see what happens. So I on the first iteration is going to be equal to 1. So let's just put that there so we remember I is equal to 1. J is also equal to 1. Okay. So what we're saying is, okay, well, as long as j is less than or equal to I, which it is, it's 1, right? We want to print j, so we're going to print down j, right? There's our 1. And then we go immediately back up to the outer loop, because the reason we go all the way up here is because now if we do plus j, guess what? J is no longer less than or equal to I, okay? So that's done, okay? So we go to the next line. So now we say I is now equal to 2. Okay. All right. Now we go back down. Now remember, here's the thing you have to remember. J is still equal to 1. Okay. So this resets every single time because it's inside this little loop. Inside the outer loop, this j is going to reset every single time. So now it's equal to 1. So is j less than or equal to I? Yep. So we're going to print j. So again, we get our 1. And then we go back up and check again. We add 1 to j, right? That's what it tells us to do right here after our loop runs, is it tells us to add 1. So now j is equal to 2, right? Is 2 less than or equal to 2? Yeah, so we print j again. So we print 2. Okay, and it's going to keep doing that, and you just have to trust me, or you can put it in Python or Java or whatever you're using and run through it, and I assure you that will allow you to print a ladder. And now if we increase this row count to say 10, it's going to print a much bigger ladder. So again, this is another good example of using code to where we can only have to change the minimum amount. And so that's one of the big concepts in programming we're going to talk about too, is you always want to only change the minimum, okay? If you're ever having to change stuff in multiple places, there's probably a better way to do it, okay? There's almost always a way to where you can only have to change something in one place. And that goes from just like the little stuff about creating variables all the way up to whenever you start doing, more complex object-oriented programming where you're doing, even actions or even abilities of objects have their own classes, and when you start using interfaces and things like that, which if that's something you guys want to see, let me know. So let's look at one more example, and I'm gonna wrap this one up. Okay, so this is another example, and I'm not gonna do the whole pseudocode, but I'll just show you example. Let's say that you have this thing. You don't have any sorting algorithms on you. You don't have the internet, because even me, like I always look up sorting algorithms. Like I don't write those on my own. Like I can write easy ones, but I just don't do that. And let's say you wanted to sort this very, very easy short array from in ascending order. Okay, this is something that's going to require at the minimum a nested loop. And the way that we know that is because there's an operation that we would run on this array in order to find the lowest number. Okay, so what we would do is we want to step through each one. Let's say we did something like we came up with a variable called min, okay, and we set it equal to 9999, and that's kind of common practice in game design. Is there's certain numbers you set, so like 9999 might be the number you set it to first, because we know that there's nothing higher than that in our array, right? We know it's not going to mess up our array. So we do 9999. Well, what we do is we look at the first one. We do use a loop to look at the first element. Okay. Is that smaller than 9999? We would say, yeah. So we would replace minimum equals 2. All right, and I'll write a little pseudocode for this, but you have to kind of imagine we're looping. We're using that same process that we just used to loop into this array, okay? And so we're like, okay, yeah, okay, that is. So then we jump to the next one. And we say, is that smaller than minimum? Yeah, it is, okay? So 1 is smaller than 2, so now we switch it with min equals 1. So we do that until we find the smallest one, okay? The smallest one in the array. Then we swap the smallest one for the first element, okay? So then after this run through of our array, all right, and I'll show you kind of where I'm getting in just a second, would be this, 1, 2, 5, 3. Well, that's closer. And so we've done one whole iteration. We went through this whole array. We found that after going through all 4 numbers, 1 was our smallest. So we replaced 1 with the beginning. Well, great. But it's not sorted, right? Because we have to do that same operation at least the number of times of elements there are in our array. So we have to do that thing we just did. Search through the array and find the minimum and replace it with the beginning. We have to do that at least 4 times. Okay, so it would look something like this. And this is where we'll end right here. And in some really bad pseudocode, it's going to look something like this. I think we had 2, 1, 3, 5, right? 2, 1, 3, 5. Okay, let's see, 1, 2, 3. No. Let's do this. Not that one, because we got to make sure we have enough. 1, 2, because I want to have at least 2 swaps. 5, 3. Okay, so again, here we go. For I equals 0. I is less than, and we'll call this A, just to give it a name, A dot length. And this is a pretty common way to determine when your array, when your loop stops, right? In the first one, we determined that we wanted 5 rows. We determined that we wanted it to count to 5, right? But in this one, we are designating that we want our loops to stop at the end of the array, okay? So it's kind of bound for us. We know how far we want to go, and we can actually use dot notation in most programming languages to access that length. All right, so now let's do I++ or plus I, whatever. So this is going to say, okay, well, I want you to run through that array. I want you to do this on the outer part, okay? So then let's get into the array, okay? The problem is, all right, so that's the thing. Remember how we said, and I don't know what's going on with my little mouse here. There we go. We said that this was going to have to run the number of units in the array, and that's what it's doing, right? It's going 0, 1, 2, and 3, okay? Because there's only 4 elements in this array. All right, so let's get into the inner array. So let's say, so let's go for j equals 0. J is less than, okay? And for this one, same thing, a dot length, right? Because we want it to go through each time, all the way. We're going to say j++. Okay, and so then we can do our code. So what we've done, and then this is where we would say, this is where we would do that block of code that was like check for smallest number, then swap. And actually, this is pretty common. Like, it's much more complex than this, but this is a pretty common concept right here, what I'm doing. I am kind of writing, like, you could pretend there's a comment right here. I'm kind of writing what I want to do before I do it, right? I've set up my loops. I know that I'm going to be looping inside this array. I know I'm going to be going through each element every single time and then bumping forward and going all the way to the end. This is an extremely inefficient sorting algorithm, but this is pretty common practice too, right? Commenting out these blocks of code that it's like, if you know how to use if-else statements, you know how to put this together, okay? But you can still see how you can set up maybe the one part of the code, comment out what you want to do, and then come back to it later. Okay, so that is my quick introduction to nested loops. Nested loops get much more complicated than that. If you have any questions about them, let me know. Put in the discussions, whatever. If you have any topics you want to go over, let me know as well. If not, have an amazing week, and I'll see you in the next video. Bye.